a lot of calculator steps on this. I'm going to remind you about turning on your diagnostic. You won't need it for number 9, but you will need it for number 13. So I'll just start it off with reminding you how to turn on your diagnostic. So I'm going to go ahead and clear my calculator just so that we're at a fresh start. I'm going to dim it a little bit. So I'm going to turn mode. I'm going to go to mode, and I want to go to diagnostic, stat diagnostic on. And what that's going to do is it's going to tell you your regression, which will tell you if it's a strong positive, strong negative, weak negative, and again we'll go into more detail about that on number 9. So we're given the table. So the table shows the median age of females when they were first married. Use the graphing calculator to find an equation for the best fit line that models the data. So basically it's asking for the line of best fit. Now it gives you a hint, and it tells you you're going to use 0, 1, 2 for the years. So instead of putting 2012, 2001, we're going to put 0. So what I would do is I would just go ahead and write that to begin with, so that you don't mess up. So I'm going to go to stat, I'm going to press enter, and I'm going to type in those numbers. And then I'm going to type in the other set of numbers. As you can see, I messed up. But that's okay. I told you we're human. That's what we do. Okay, so all that to put in those numbers. So it's important that you make sure that you put in the numbers accurate. Otherwise, you'll get an even weirder number than you're going to come up with right now. So I'm going to go stat over 4. I'm going to press enter. Now, just a quick reminder, I'm going to look at the R, that's your regression. So this would be a strong positive because it's 0.98 and it's closer to 1. Or you can think of it as money. It's closer to $1. So 98 cents is closer to $1. Okay, so I'm going to round these off to 2 decimal points for both A and B. So A is going to be 0.19. And B is going to be, it's already rounded for us, is 24.95. So now I'm going to write that as an equation. So y equals 0.19x plus 24.95. And that's your answer for that problem. Okay. So let me get you to go to number 10. So below, the graph below shows the annual salary for employees based on their years of formal education. Given these results, what is the best estimate of the annual salary for an employee with 17 years of formal education? Okay, so you're going to want a good line of best fit. Now you can't just draw lines and just connect them here, because if I connected just these two, all these dots would be underneath. So you want to try to get the numbers evenly distributed on top and the bottom. So I'm going to say roughly, by connecting these two lines, I should be okay. Nope, should have been these two. which is why I should have used a pencil. So if you look, you have 1, 2, 3, and here you have 1, 2, 3. So I'm going to go to 17. Since I didn't draw a very good line, you can't really tell, but I'm going to say that's about anywhere between 84 to 85,000, or yeah, 1,000. So I'm just going to put a K for 1,000, and that's your answer. It'll be clearer on the test. So again, on this one, you want to draw a good line of best fit. Since it said you wanted 7 at year 17, I went up to 17. I'll highlight this so that you can see. So this is where it met. That's roughly 84. It could be 85, somewhere in there. Okay, so number 11. So we want to describe the change from the equation f of x equals x that generates the equation g of x equals 1/4 x plus 2. So if you'll remember, the other day we talked about these questions. Did the line reflect? Did the line shift? Did the slope of the line get steeper or flatter? Okay, so as you can tell, we have 1/4 with the slope, and we have 2 added. So that means that g of x became less steep, and I know that because this number is less than 1, so that means it became less steep, and it shifted up 2 units. And how do I know that it shifted up? Because it added 2. Okay, and just in case, because I'm not going to tell you not to use your calculator, you can check it in the calculator and you can see clearly that these two things are true. Okay, so I'm going to press graph. There's the original line, that's f of x, and there's g of x. As you can see, the red line is less steep, and from the blue to the red, it went up 2 units. Alright, so let's read number 12. So you have a slope. The slope is doubled, and the y-intercept is changed to 6 for the equation f of x equals 3x minus 5. Write the equation of the new function. Okay, so here it's telling you that your slope is doubling and that your y-intercept is changed to 6. So this is my slope, and this is my y-intercept. So my new equation, g of x, is doubled. Well, 3 doubled is 6. And my y-intercept is changed to 6. So there's my new equation. Now I want to take this a step further, and I want to compare the lines. Okay, so our original line is the blue one, and the new line, g of x, is the red one. So do you see how the line now goes, it goes up faster? Well, that means it got steeper, and if you look, the blue line, to get from the blue to the red, it shifted up. And technically, if I count every one of these dashed lines, or dashes on the lines, it would be 11. So technically we would say that g of x became steeper and shifted up 11 units. So that's just extra. This is extra to help you. Alright, so number 13, this is the one that I told you that we would need the linear regression. So we have to use our calculator on this. You can actually do it by hand, but it's extremely difficult. There's a very long formula for it. Okay, so I plug these points in, I use stat, and it wants to know the strength of the data. So if you look, this is 0.48. Okay, so we know that it's positive, and if you'll remember, there was a quarter sheet that I gave y'all. This should tell you that it's a weak positive. And the reason why it's weak, earlier I told you 0.98 was close to 1, while 0.48 is further than 1, and that's why we call it a weak positive. Still positive, but it's a weak positive. Okay, number 14. So we're going to identify association and causation for the scenario. So as the number of inches of rain increases, the level of water in the lake rises. So as it rains, it's saying that the lake water would go up. So to me, that says that it's going up. And it could be going up like this, but it's going up. So I would say that it's positive. Now, does the rain cause the water to rise? So is there a causation? Does one affect the other? So yes, it does. If it rains, then the water is going to increase. If it doesn't, the water stays the same. Okay, so number 15. This is very similar to number 3. So if you'll remember, this is where I told y'all to write the equation twice. And what we'll do is we'll cancel out the x and we'll cancel out the y on the other. So I'm going to divide by -4. So y is equal to -3. I'm going to divide by 3 to get x by itself, and x equals 4. So that means I have a y-intercept of -3 and an x-intercept of 4. And I'm going to connect the two dots. And there's my equation of the line. So write it, solve for one letter, then solve for the other. Alright, last problem. So we're in a graph. In order to graph, I need my y-intercept and I need my slope. So my y-intercept is the number that's all by itself. It wants to be alone. So 1, 1. And our slope is -3. So remember, when you're dealing with slope, you want it to you want it to be written as a fraction. So I'm going to just put that over 1. So my first thing I need to do is go to the y-intercept. Remember, this is a negative slope, so here's positive, here's negative. This is the direction of the line, or this is the direction the line should be. So I'm going to go up 1, 2, 3 over 1, or I could go down 1, 2, 3 over 1. And I'm going to connect the 3 points and draw a line. And that completes the lesson.